The exam just around the corner, it's important to focus on what really matters. Hi, I'm Terry. I've been teaching additional mathematics for over 25 years, conducting SPM seminar in school and helping thousands of students to achieve excellent results. I created Express Notes to help you revise effectively by focusing on key concepts and important exam questions. Today, we'll focus on chapter 7.2, parallel and perpendicular lines. Let's begin.
All right, can't believe it. Okay, so let's talk about this one. Well, it's a bit unlikely to that for them to ask you how to prove that they're parallel, but just in case, you see my diagram here. I think remember before your trial exam, someone asked me this. I did actually show how to prove it, somewhat similar to this. But it's a bit hard because you have to draw a diagram and show like this. When you move it up, alternate angle, the angles are the same. Basically, gradient is your tangent, right? So therefore, your M1 equals M2. Okay, you know what I'm saying? When two lines are parallel, gradient must equals to each other. The gradient M1 must equals to M2. Okay, so for this parallel perpendicular line, normally what they can ask you is they ask you to find the value of unknown in your equation. These two lines are parallel. Find out the value of unknown k. So for k, right, I bring over ky equals 4x minus 7. Your y is 4 over kx minus 7 over k. So for the second one, right, I like to use negative y-intercept over x-intercept. My y-intercept, this is your M1 by the way. M1 is 4 over k. Your M2 is negative y-intercept over x-intercept. This is 2 over 5. Since M1 equals to M2, 4 over k equals 2 over 5. Cross multiply, k is 10. So when two lines are parallel, the gradient of the first line, we know they are equal to gradient of the second line. But maybe they may give you 3 points like this, point A, point B, point C. And then they say point A, I want to find equation straight line that passes through C and parallel to line AB. So number one, you got to find gradient of AB by using y2 minus y1 over x2 minus x1. Number two, since they are parallel, gradient must be equal. Number three, we form the equation of the second line here by using y minus y1. In this case, I use y3. Y1, y3 is the same, mx minus x1, or in this case, x minus x3. Remember this formula? Y minus y1, mx minus x1. Okay, so I'm going to show you one example. Okay, maybe we do a rough sketch. Because they say there are 2 points here, point R, point S, right? You're finding equation straight line parallel to line joining RS and passes through T. So first thing we need to do is to find gradient of RS. We can do so by using y2 minus y1 over x2 minus x1. So this is 5 divided by negative 2. Answer, negative 5 over 2. Now, number two, we know it passes through point T. Okay, so the gradient of the second line, since it's parallel, it must be the same as negative 5 over 2 as well. Then we use y minus y1, gradient m, x minus x1. So you can leave it in any form. You can change to general form or intercept form, right? Now, if the question don't mention actually any form will do, but okay, let me just multiply inside first, right? Notice the 2, I times it over 1 by 1. Then I multiply the negative 5 inside, right? Then I make y as a subject. This should be 8. Maybe I write negative 5x plus 8. Your y is negative 5 over 2x plus 4. So here, notice I write in we call it gradient form. But if you don't want to write in this form, you want to write general form, is all right. In our previous example, you're given 3 points. Now you're not given points. You're given the equation of that line itself. Okay. So what we have to do is to find the gradient of this line. Guys, find the gradient of this line by changing it to y equals mx plus c. You know the gradients are equal. Then you sub in y minus y1, m x minus x1. But personally, I feel, right, guys, I don't know why they don't want to teach you this method. When two lines are parallel, do you know that your ax plus by value must be the same? This one I put a plus c, maybe I can put a plus d. Do you know when two lines are parallel, your ax plus by values are the same one? Right? So it's kind of easier if you just take this point, you sub inside, you find the value of d. Then you rewrite it, then you get the answer. Whether you write D or you write equals to C, it doesn't matter. Right? But I don't know why school doesn't want to use this. They still use the traditional change to y equals mx plus c method, which is a lot longer. Okay. I'll show you this method, the y equals mx plus c method. Bring over to the right, make y as a subject. So it's 14x plus 9, divide by 6, 7 over 3x. 9 divided by 6, 3 over 2. So this line, right, has gradient of 7 over 3. Well, the second line is parallel to it, so it must have the same gradient. We just have to do y minus y1. Take 5 out. Your y1 is 5. Gradient is 7 over 3 x minus x1. So multiply over, rearrange it, 3y 7x plus 36. If you divide by 3, you will get this answer. This one is a bit more difficult. I think the likelihood for them to ask you this in exam a bit lower, but although it is possible, if you want to know, come I tell you quickly, briefly how to prove this. Okay, so you have to draw a triangle. Without triangle, very hard to explain. Like for example, see, this is the first triangle here, triangle PQS, right? So what is your gradient? The gradient is QS divided by PS. You understand my drawing here, not? Then for QR, right, we draw a second triangle. This second triangle here, your QR is negative QS over SR. Now, if you look at the yellow, the red triangle, right, what is tangent? Tangent is opposite over adjacent. My opposite is QS, adjacent is PS. So QS over PS is my tangent. Okay. Now, because this is 90, right, we assume that this is 90. This angle here is 90 minus, if this is 90, this is alpha, this is 90 minus alpha. And the next part over here should be alpha. So for this alpha, right, this tangent alpha for the second one is SR over QS. Now, we know if I take SR over QS, I invert it, it becomes QS over SR is 1 over tangent alpha. But since I have a negative in front, I need to put a negative 1 over tangent alpha. So I got two gradient already. I got gradient of PQ, which is M1. I got gradient QR, which is M2. I multiply together tangent alpha times negative 1 over tangent alpha. What's the answer? Negative 1. So this proving, yes, a bit more difficult, right? But I think if they were to ask you, they will have to give you the diagram. Because if they ask you, prove this, there are a lot of people don't know how to do it. Because you have to draw a triangle, these two triangles together. You heard what I'm saying? All right. They probably have to give you a diagram and ask you to prove based on the diagram. Now, let's look at example 7. So we know when two lines are perpendicular, m1 dot m2 equals negative 1. So first, what is the gradient of this line? We can change it to y equals to mx plus c divide by 6. This is negative p plus 1 over 6x plus 5 over 6. So gradient m1 is negative p plus 1 over 6. Okay, for the second one, right, you can choose to use negative y-intercept over x-intercept, but be careful. For negative y-intercept over x-intercept, we call it intercept form. This one, your number one, this must be a plus. So I change it to plus. So the negative sign I assign to 3. Number 2, the 2 on top, I bring it down. So it becomes negative 3 over 2. Your outcome is now 1. So my M2 is negative y-intercept over x-intercept. My M2 is 3 over 2q. Now, then they say they are perpendicular to each other. So my M1 times M2, the result must be negative 1. So for me, I will cancel the negative and negative. I will also cancel 6 and 3, left with 2. So let's multiply together. P plus 1 over 4q equals to 1. I'm finding P, right? So P plus 1 is 4q. P is 4q minus 1. There you go. You got your P in terms of q. So you're given a coordinate of 2 points on the perpendicular lines. So if you want to find gradient, right, of this line, because you're finding equation, we find this gradient of this line first. I do y2 minus y1, x2 minus x1. Since the second line is perpendicular to the first line, we do m1 dot m2 equals negative 1. Or we say, you see, this is actually for m1 dot m2 equals negative 1. So we say your m2 is negative 1 over m1. Yeah, we call it a negative reciprocal. And to form the equation of this line, we just use y minus y3. I use y3 because this point is x3 by 3. Yeah, mx minus x3. Okay, let's look at example 8. Yeah, okay, we are given 3 points. Okay, you want to find equation of the point of a line perpendicular to a straight line joining PR. This is P, this is R, and it passes through Q. Number one, let's find out gradient of PR, which is y2 minus y1, followed by x2 minus x1, minus a plus. So this is 6 over 8, 3 over 4. Okay, number 2, because PR is perpendicular to this line, right? So 3 over 4 times m2 must be negative 1. Gradient of your second line is negative 4 over 3. Okay, so we know the gradient of second line. We know it passes through point Q. I have to use coordinate point Q. Y minus y1 gradient mx minus x1 multiply over 3y plus 3 minus 4x plus 24. 3y equals to minus 4x plus 21. Notice that we can divide by 3. So here, when I divide by 3, you get negative 4 3x plus 7. We have done a perpendicular lines given 3 points, right? So this one you're given an equation. So very simple, changes to y equals mx plus c. Identify your gradient, m1. Then you use m1 dot m2 equals negative 1 to find the gradient of the second line. And then use the equation y minus y1, mx minus x1 to find equation of the second perpendicular line. Okay, so number 1, can we change this to y equals mx plus c? Y over 2 is negative 3x plus 5. So my y is negative 6x plus 10. My m1 is negative 6. So your perpendicular line is m1 dot m2 equals negative 1. My m2 is 1 over 6. Then we use the equation y minus y1, mx minus x1. For me, I times it over 6y minus 24, x plus 7. 6y is x plus 31. Divide by 6, 1 over 6x plus 31 over 6. That's all. Again, now you can change to general form or gradient form. This is gradient form. Okay, guys, you already know about perpendicular bisector. When two lines are perpendicular to each other, number 1, we know the gradient must be times together must be negative 1. But perpendicular bisector, not only that they're perpendicular, they must also, the word bisect means you, not bisexual, but you cut them into 2 equal half, right? So, all right, it must be passing through the midpoint. So you find the gradient m1, you find the gradient m2, right? And then you use the midpoint, coordinate point C, and then you form the equation of perpendicular bisector, okay? All right, so let's look at this. Now, for me, I always do a rough sketch. Let's say this is your P, 1 minus 2, this is your Q, minus 5 minus 6. Let's find out the midpoint. The midpoint, the sequence is not important. You want to find midpoint first, you want to find gradient first, also can. My gradient minus 6 minus 2, minus 5 minus 1. This is minus 4 divide minus 6, positive 2 over 3. This is your m1. You multiply with your m2, the result is negative 1. So my m2 is negative 3 over 2. All right, so I've got the gradient of second line. I need to find the midpoint though. My midpoint is 1 minus 5 over 2, minus 2 minus 6 over 2. This is minus 2 and minus 4. So let us find the equation now. Y minus y1. My gradient is negative 3 over 2, x minus x1. Now, minus, you can just write plus. This is 2y plus 8 minus 3x minus 6. 2y is minus 3x minus 14. Your y is minus 3 over 2x minus 7. Find the equation perpendicular bisector of this line. But they ask you to find perpendicular bisector of AB. But first, we need to find out what is your A, what is your B. Okay, we change this to intercept form. 5x plus 4y equals to 20. Remember, intercept form must be 1, must be equals to 1. So I'm going to divide by 20. So x over 4 plus y over 5, the result is 1. So picture this. The graph should look something like this, where this is now 4, this is now 5. My x-intercept is 4, my y-intercept is 5. And your x-intercept is your point A. You can write here, A is 4, 0, and your B is 0, 5. What are we finding? We're finding equation of perpendicular bisector. So you just have to do one extra step. That is, you need to find what is the coordinate point A and B first before you can find equation of perpendicular bisector. Now, for gradient of AB, right, we use negative y-intercept over x-intercept. And since I'm finding the perpendicular line, right, we can use m1 times m2 equals negative 1. My m2 is 4 over 5. Then I find the midpoint. Okay, what is your midpoint? We take 4 plus 0 divided by 2. 0 plus 5 divided by 2. Your answer is 2 and 5 over 2. 2 and 5 over 2. I got this point. Now, let's form the equation then. Y minus y1 equals to m. What's your m? 4 over 5, x minus x1. So now if you find that this number is very annoying, you don't like fraction, you can just multiply everybody by 10. So when I times 10, this is 10y, 5 over 2. The 10 cancel with 2, left with 5, 5 times 5, 25. So when it times with 10, picture this, there is a 10 of 4 over 5. Cut, left with 2, 2 times 4, this gives us 8 with the x minus 2. My 10y minus 25 is 8x minus 16. 10y is 8x plus 9 here. 9, right? You can divide by 10, 4 over 5x plus 9 over 10. Now, you can leave in any form. Like I say, sometimes in exam, they may ask you to give in general form, right? Sometimes they may ask you to leave it in gradient form, right? If they don't mention, you can actually stop here or here as well, or any other form. If this video helped you, you can get my Admaths book from Shopee or Lazada, or by searching Perliti. For full step-by-step learning, check out my e-course or join my classes at Pusat Tuition Perliti. Remember to like, subscribe, and share. See you in the next video.